Welcome to Math with ACE, focusing on statistics. We are looking at hypothesis testing. Today we're going to check through the four-step process that we like to do, which is where we state our null and alternative hypotheses, identify our parameter and context, we check our conditions, and we then do the math where we do some calculations, and then we draw conclusions based on the calculations that we did. Okay, for this problem, we're going to start out by, this question asks us to state the alternative and the null hypotheses, draw a graph of the distribution with the null value as well as the sample data value, calculate a test statistic as well as the p-value, and decide if there's evidence for the claim. So it's not asking us to complete the whole four-step process. And I think one of the reasons is I don't think it meets the conditions, but let's see what we can do here. Suppose a baker claims that his bread height is more than 15 centimeters on average, and several of his customers do not believe him. To persuade his customers that he is right, the baker decides to do a hypothesis test. He bakes 10 loaves of bread. The mean height of the sample loaves is 17 centimeters with a standard deviation of 0.5 centimeters. Assume the distribution of heights is normal. Okay. State the null and alternative hypotheses. So first of all, this problem gives me the mean height, and it talks to me about means. This is numerical data. I'm measuring something. So I'm going to be doing a hypothesis test for means. Stating the null and the alternative hypotheses then for means means I use mu. And remember, my null hypothesis is always a statement of equality. Now the alternative is the claim where I'm doing either less than, greater than, or not equal to. And the customers do not believe that his bread height is more than 15 centimeters. So I'm using 15 as my measurement and more than as my claim. But what is mu? Mu is the true population mean height of bread. I'm not given a level of significance to test here, and we're going to be looking at a p-value. So let's just maybe use 0.05. We'll say, 5%. It's not critical. If I am saying that the heights are less than 15 and they're not, it's not or more than 15 and they're not, it's not a huge issue. If I commit a type 1 error, I could use alpha equals 0.1 if I wanted to, but 0.05 is fine. So now drawing a graph, I am looking at this distribution here. Remember, this is for means, and so this would be a t-distribution. And I am assuming that my value is 15. And then I need to determine whether with my 17, where that lives, and how far away it is depends on the standard deviation. But let's just say we have 17 here. And we're trying to figure out what this area is going to be. What's that probability? So let's calculate our test statistic. So this is t. Remember, we have our sample average minus the hypothesized value divided by the standard deviation of the sample divided by the square root of the sample size. Filling in the numbers, the mean height of the sample was 17. The standard deviation of the sample was 0.5, and the sample size was 10. So we're going to do 17 minus the hypothesized value of 15 divided by the standard deviation, which is then divided by the square root of the sample size. 17 minus 15 is 2, and then I'm going to use my calculator to determine 2 divided by, and then I'm going to do 0.5 divided by the square root of 10. And let's do 0.5 divided by the square root of 10 just to abbreviate. This is 0.158. I get a t-score of 12.658. That is more than 12 standard deviations away from the mean. So my drawing is completely inaccurate. I would say that my 17 needs to be way over here off the charts, right? 12 standard deviations away. Well, remember, 99.7% of the population falls within 3 standard deviations. So to be 12 away, it's very, very small. I would say my p-value is ridiculously small, almost 0. So the p-value that corresponds with that is roughly 0, which means that there is almost no chance that this could have happened randomly by chance if the baker really did have a height of 0. So I think there's evidence that it's more than. So let's say, because our p-value of 0 is less than our alpha equals 0.05 level of significance, we reject the null. And when we reject the null, that means that our assumption is not right. We're going with the claim. So we have evidence to support the claim. And I want to give context here. We have evidence to support the baker's claim that the true population mean height of bread is more than 15. Okay. If you were to go into Statlet, we can use these calculations with a t-distribution. What is the degrees of freedom? We need that information to go into Statlet, which we're going to do now. Okay, so this is a t-distribution, and we have degrees of freedom 9 because our sample size was 10. So n minus 1 is 9. I do like to plot the normal distribution, so we're going to plot this distribution. And what we're going to do is we're going to calculate the value or calculate the area that corresponds. It is a greater than problem. So to the right of 12.658, that was our t-score. So calculating the area, you cannot see the probability because 12 is so far away. We even have 4 standard deviations listed on this distribution, but it does tell you that the area is about 0% because it is so far away. So hopefully this was helpful in performing hypothesis testing, and we will do some more examples in our next set of videos.